This video is on scientific notation. Scientific notation is just a way of expressing a very large number or very small number as two factors. Two things you need to keep in mind with these factors is the first factor must be greater than or equal to 1 and less than 10, and the second factor must be written as a base of 10. Before getting too far into our examples, let's first take a look at our base 10. Let's do a little review first. Our exponents are telling us how many times we're multiplying a certain number by itself. So 10 squared is going to be 10 times 10, because the exponent is telling us that we're multiplying it by itself 2 times. 10 times 10, when factored, is 100. 10 to the negative second power is not negative 10 times negative 10. In fact, it is 1 over 10 times 1 over 10. When we simplify that product, we get 1 over 100. We could also write this as a decimal as 0.01. Recall from our negative exponent video, there is a reasoning for this. If we start with 10 squared, we get 100. 10 to the first power is 10, or it's the same thing as dividing by 10. Since we go from 10 to the second power to 10 to the first power by dividing by 10, we're going to continue this pattern on down. So 10 to the 0 power is 1. 10 to the negative first power is 1 over 10. Notice there is no negative sign here. And 10 to the negative second power is 1 over 100. Again, no negative sign. Here we have two examples that look remarkably similar. The only difference is the exponents that are being used. The one on the left is using a positive exponent. The one on the right is using a negative exponent. So solving these, we'll see how they differ. The one on the left, we're doing 3.1 times 10 squared would be 10 times 10, or 3.1 times 100. Simplifying that even further, 3.1 times 100 gives you 310. Looking at the expression on the right-hand side, we'll take that through the same process, so it'll be 3.1 times 1/10 multiplied by 1/10. Simplifying that, we get 3.1 times 1 over 100. And then simplifying that even further, we get 0.031. Again, notice no negative sign involved here. This all becomes a fraction. Very common error that students make this negative. It is not negative. A trick that you can do with scientific notation is look at the exponent. If it is positive, you can move the decimal point over that number of times to the right. So 3.1, 2 times over, that's 1, 2, and you can see it here. Starting between the 3 and the 1, 1, 2, you get 310. With the negative exponent, you're going to move it the same number of times, this time to the left. So the decimal point started at 3.1, moving it over 1, 2 place values to the left. Typically we put a 0 in front of the decimal point just to indicate that that decimal point is there and we don't forget about it. Alright, here are 3 practice problems to work on. Go ahead and write these down at this time. Pause the video, try and solve them, and then restart the video. Looking at our first example problem, we have 4.882 times 10 to the 5th, so we're going to multiply the decimal by 100,000. When you do that, you get 488,200. Notice with the exponent, you can move it to the right 5 spaces, 1, 2, 3, 4, 5. and get the same result. For the one just below that, multiplying it by an exponent of 8, so that would be equivalent to multiplying the decimal by 100 million. When you do that, you'll get 234 million, or the same process, starting at our decimal between the 2 and the 3, you can move over 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right. And our final one with a negative exponent. Remember, this is going to be converted into a fraction. It is not going to be a negative number. So this is equivalent to multiplying the number by 1 over 100,000. 100,000, 1 over 100,000 represented as a decimal would be this. And starting at the 1, in between the 1 and the 1, moving in over 5 places values to the left, 1, 2, 3, 4, 5, we can see where the decimal point will be properly placed. Not only will you need to be able to write numbers from scientific notation to standard notation, you'll also need to write standard notation, which is what you see here, into scientific notation. So go ahead and take a moment to write these problems down. Pause the video and write them into scientific notation. For the first one, we need to move our decimal point, which is over here, all the way in between the 2 and the 0, because we need a number greater than or equal to 1 but less than 10. So it has to be less than 10. The easiest way to do this is just to do little bunny hops where the decimal point is to where it should be. So take advantage of the commas. You can go 3, 6, 9. And of course we have a power of 9 for our exponent. For the second one, since it is a decimal point and it's going to be less than 0, our exponent is going to be a negative. So we're going to count over 1, 2, 3, 4, 5. And since it's, again, less than the value of 1, it's going to be a negative 5. That is equivalent to 9.1 over 100,000. And our final one, a little bit easier. We're only going to be moving it over 2 place values. So it'll be 5.4 times 10. And since it's less than 1, it's going to be negative 2, which is equivalent to multiplying by 5.4 times 1 over 100. And of course you can see that here, tens, hundreds. A few things to remember about scientific notation. Your first factor must be greater than or equal to 1 but less than 10. And negative exponents lead to a fraction and not a negative number.